Welcome to the exercise of practice on winding of small transformer. On completion of this exercise, you will be able to
dismantle the transformer cores and determine the size of the winding wire for the primary and secondary winding. Wind the primary and secondary windings over the bobbin. Stack the cores and terminate the winding end on a terminal board. Test the transformer for insulation, transformation ratio, and performance. Let us collect the tools and materials required to do this practical. Scissors, steel rule, firmer chisel, hammer, ball pen, iron soldering, double-ended spanner set, mallet hardwood, nylon mallet, double-bladed knife, super enameled copper wires, empire sleeves, air dry varnish, resin core solder, soldering paste, smooth emery paper, fabric-based fiber sheet, cotton cloth. Dismantling the transformer for rewinding. Note down the nameplate details in the table. Draw the end connection terminal markings of the transformer. Desolder the leads and remove the terminal strips if they are attached to the core. Loosen the nuts of the core assembly and remove the screws if any. Remove the clamps attached to the core. Gently tap the transformer core with nylon mallet so that the core gets loosened. Remove the stamping starting from the center of the core using Hylam or fiber knife. While stripping the core, see that the stampings are taken out straight without bends. Remove all the stampings and record the following in the table: type of core, number of stampings, of shape. Wipe the bobbin and winding with a cloth. Record the dimensions of the coil in the table with and without insulation and prepare a template to check the winding's height and length. Strip off the winding carefully. During the stripping process, record all the particulars in the table. Draw a schematic diagram of the primary and secondary sides of the transformer from the above findings in your record. Clean the bobbin. If it is not damaged, the same bobbin can be used. Preparation of bobbin. Measure the dimensions of the bobbin and record it in the table. Rewinding of transformer. Prepare and select a suitable mandrel for the prepared bobbin or prepare a wooden block as shown, depending upon the design of the winding machines. Clamp the mandrel or wooden block in the winding machine. See to it that while clamping the mandrel or wooden block, under no circumstances the work becomes loose during winding. Fit the bobbin tightly to the mandrel of the winding machine with the help of fasteners, so that the bobbin turns along with the mandrel without play. Adjust the feed of the winding machine to suit the selected winding wire size by friction drive or by changing the gear. Adjust the transverse feed of the winding machine guide so that the length of the bobbin's inner side will remain the size of the coil as in the original. You may need several trials before the final setting is ready. Place one layer of paper or cloth as core insulation on the bobbin smoothly and without crease. Solder a connecting lead and sleeve at the beginning and end of the selected winding. Place the lead wire at one end of the bobbin and take it through the bobbin flange outlet and tie it with a knot to avoid slipping. If the winding wire has sufficient thickness, soldering of connecting lead wire is not necessary. Start the winding and complete at least one layer to check whether the coil length is well within the bobbin as in the original. If not, readjust the transverse feed. Start and continue the winding layer by layer, providing the necessary in-between insulation and the specified number of turns in each layer as per the data taken already. After the designated number of turns are wound, solder the end lead and take it out through the bobbin flange outlet. If a coil has several tabs of winding, never cut the wire. Instead, fold the length into a long loop and carry the wire to continue the winding. The looped wire can then be barred and connected outside the coil. After inspecting the primary winding, wrap the winding with sufficient insulation according to the data taken. Select a suitable secondary winding wire, verify with data taken already and continue winding as done on the primary side. The transformer may be provided with one or more secondary windings or tapped windings. At the end of the winding, wrap and bind the insulation on the winding tightly. Bindings must cover the winding fully, be free of creases and not project beyond the coil disc of the flange. Inspect the coil for proper termination of lead and check the size by using a template and data taken. Test the windings for continuity and short circuits using a multimeter. Set the multimeter in continuity mode, place it between primary windings, that is starting and ending terminals, and secondary windings, that is between starting and tappings. Ensure the beep sound for continuity. To test for short circuits, place the multimeter probes between any primary and secondary terminals one by one and ensure no beep sound occurs. Stacking of transformer cores. Insert an E lamination into the bobbin from both sides. Place the right hand side laminations below the one inserted from left hand side. Place an I lamination to the free end of the left hand side E piece. Ensure that the slot in the I is above the corresponding slot on the right hand side E lamination. The laminated assembly should be flush and lying flat. Insert the second E-shaped laminations from the opposite side. Ensure that it fits snugly against the bobbin. Place an I-shaped lamination in position. Ensure that it lies flat on the first E lamination. Likewise, insert the laminations alternately without any gaps. Ensure that when all the specified quantities of laminations are inserted, the assembly has the right dimension from loose laminations to correct interpolated laminations. Fit both the top and bottom clamp plates on the assembly as in the original. Pay particular attention to aligning the core slots in the laminations. Ensure that the fixing bolts can be easily inserted. Push the fixing bolts through the clamp plates. Use the specified fasteners and tighten the assembly. Varnish the transformer by dipping it in air dry varnish and draining it. Fit the specified insulating sleeves over the lead out wire. Obtain the specified terminal board and pass each lead out through the specified hole. Ensure that all the sleeved leads are correctly positioned. Check that all the sleeved leads terminate at each hole, that is, no bare leads should be visible in the terminal board. Place the terminal board in position. Secure the terminal board with the specified studs. Check that no leads have been trapped between the terminal board and the core. Make the specified mechanical joint between each lead out wire and its soldering tag. Solder each joint and cut off the surplus wire ends. Test the primary and secondary windings for continuity with a measure. Measure and record the primary and secondary winding resistance. Measure and record the insulation resistance between windings and frame. Connect the primary winding of the transformer with the rated voltage. Keeping the secondary open, test the primary and the secondary voltages. Record it in the tabulation. Observe the vibration sound of the core. If it is abnormal, tighten the stampings. Also check the tightness of the coil. Connect the transformer with the suitable load so that full load current passes through the secondary. Record the voltage and current at load. Keep the transformer on full load for 8 hours continuously. Observe the change in temperature of the winding and core by touching. If the temperature rise is within the class of insulation, the transformer is OK. Testing of the transformer after winding. Collect the following data: output, power and frequency, input and output voltage, duty rating, intermittent or continuous, and verify.
I hope after watching this video, you will be able to
dismantle the transformer cores and determine the size of the winding wire for the primary and secondary winding. Wind the primary and secondary windings over the bobbin. Stack the cores and terminate the winding end on a terminal board. Test the transformer for insulation, transformation ratio, and performance.
This concludes the exercise of practice on winding a small transformer. Thank you for watching. See you in the next exercise.